Hey y'all, in this intermediate Python tutorial on the Future Programmer YouTube channel, we're going to talk about the concept of decorators in Python. So let's get started. The concept of decorators in the Python programming language is a very interesting concept related to functions. So let's take a look at what it's all about. Now, before we get started learning about decorators, we first need to know a few important properties of functions that are crucial to learning decorators. And while at its surface, functions can be really simple, just a block of code that we can reuse after defining in our programs. Python functions actually have some interesting and defining characteristics that you may not have known before, which are important to learning decorators. First off, functions are objects. You may have heard the saying that everything is an object in Python before. Now, this does not only apply to data like strings, ints, and lists, but also to functions. So that's right, Python functions are also objects, meaning that they support operations available to the other types of objects like booleans and floats in Python, which means that functions can be assigned to variables, just like other objects. Here we have a function defined called func, which just prints something out. And we're assigning func to a variable called myvar. Notice the lack of parentheses after the function name, which means that we're not calling the function. Instead, we are assigning the definition of this function to this variable right here. So if I run this code, we can see that calling func will give us hi, and calling the new variable, our myvar function, will also give us the same result, hi. Another property that is due to functions being objects in Python is functions can be arguments. They can be inputs to other functions. So here we have three functions. We have f2, which prints something out. We have f3, which also prints something out. And then we have f1, a function that takes a parameter. Now we don't really know what this is just looking at this line right here, but on line 2, we can see that we're calling the function passed in. So f is a function definition that we're passing into f1 and we're calling right here before printing out f1. So if I call f1 passing in f2, notice the lack of parentheses again. So if we do this, we'll see f2 and f1. That is because when we call f1 passing in this function as f, we are calling f2 here and then printing out f1. So we get this and then this as reflected in our output. And after our blank line print statement here, we're calling f1 again with this function passed in as f. So we're calling this line right here, and then we're printing out f1, which you can see in the output right here. We can also define functions inside of other functions in Python, which is called nesting functions inside of one another. So here we have a function called outer. This is a normal function, I suppose. And then inside we have a nested and inner function called inner. And this definition you can see is nested inside of our outer function, and we have the proper indentation just like we normally would. So this function is defined in the function outer. And we're calling the inner function after we define it. So if I run this program, we'll see inner printed out. So if we run the outer function, we'll define this function and then call it, which means we get this output printed out. Now, if I try to call the inner function outside of this outer function, we'll see a name error saying the name inner is not defined. So this is only accessible inside of its kind of parent, its outer function. Now here we have another example of nesting functions inside of one another. And in this case, the difference is that instead of calling inner inside of outer, we're returning the function inner. So this is an object. We're defining a function, and this function is an object. Therefore, we can return it from our outer function. So if I print out the result of calling outer, we will see inner. So this will be the equivalent of printing out inner without the parentheses. And we will get function outer.locals.inner at this particular memory address on my computer. So we're printing out the memory that is associated to this function definition because that's what's returned right here. If I run outer parentheses and then another pair of parentheses, then we'll get inner printed out. This is giving us the function inner. And this parentheses is calling that function inner, which gives us the output of the inner, the string right here. So now let's talk about decorators in Python. Python decorators allow us to change a function's behavior without changing the function's definition. For example, if we want the functionality of a function to be protected with a login and a password, we can use a decorator to decorate that function so that we need to first verify the user's identity before accessing the function's code or its functionality. So here is a kind of generic example of a decorator just for you to understand how decorators work before we get into more interesting examples. So here, what we have is we have two functions defined. We have the decorator function, and then we have a function called f. Let's start up here. This is our decorator function. Notice how it's just like any other function. We have a function name, and then it takes one input. In this case, we call it func, which kind of implies that it's going to take a function as parameter. And then inside of it, we have a wrapper function, a nested function called wrapper. It doesn't matter what you call it, but you'll have to return it at the end of our decorator function. Inside of wrapper, we can do whatever we want. And remember, this is a function definition, therefore we can call it inside of here. So our wrapper is going to print out wrapper, and then it's going to call the function that we passed in here. Lastly, we return the wrapper function. And here we have a function, pretty simple, it's a function called f, and it prints out f. But notice the syntax on line 9. We have the @ symbol, and then the name of our decorator, which is just decorator in this case. Now, if we don't have this line right here, you would expect that running f would give us the output of f, and that is correct. But if we have this line @ decorator right here, we'll see that we get wrapper and then f. Now we never defined the word wrapper to be printed out here, so what happened was, because we're decorating the function f with decorator, we're actually calling decorator passing f as func, and then we're calling the function returned by decorator. So what happened was f is passed in as func, and then we define a function that will print out wrapper and then call our function f right here, and then that function definition is returned and called. So we get wrapper as printed out right here, and then we call our function, which gives us the output of f. And that's pretty much what we just talked about. And here is a more practical example of using decorators in Python. Now we'll talk about how we can use *args and *quoargs, two things we talked about in a previous lesson, to pass arguments into the decorator, but let's first take a look at this example without that. We have a decorator. It's not called decorator, but it's a decorator right here called check identity. It takes a function parameter. You can call this whatever you want as well. I just called it func to make sure that I know it's a function. And then we have a wrapper function. And inside of this wrapper function, we check something. We check if the input given by the user provided the prompt username. So if the user types in the correct username called admin, we're going to call the function that we passed in here. Otherwise, we're going to say print unauthorized. And this is just a pretty simple and silly example that I made up. If the username is admin, we will let the user access the function's functionalities. Otherwise, we'll say unauthorized, and then we return the wrapper function. And we have two functions decorated by our decorator function, check identity and check identity. So we have enter library and borrow book. These two functions are decorated. Therefore, if I run this program, we'll see that calling enter library, as we can see here, is actually going to first run this code right here. It's going to ask me username, and it's going to check, is it equal to admin? So if I run, let's just say admin here, and we'll see you have entered the library. If I enter the correct username, then this code will run. Now, if I enter now this is the same idea with this right here. So if we call borrow book, it's the same idea, just with a parameter, but we'll talk about that in a second. So here, if I enter something else, let's say I enter admin in all caps, we'll see that we get unauthorized. So we're still running this code here. We just went into the else statement, and we never ran our function that we passed in. Now let's talk about the star args and star quarks business here. So we have a function that takes a parameter that we want to decorate with our decorator check identity. Now, how can we do that? If we don't have these star args and star quarks, if we delete this, we'll see that running enter library still works. I can enter admin. It's going to print out you have entered the library. But here it says wrapper takes 0 positional arguments, but 1 was given. So what happened here was because we need to pass the when we call the function right here, the borrow book function, we need to have a name that is passed in. And we don't have anything passed in the wrapper definition, so Python threw us an error. So we need to have a star args and star quarks in both the wrapper function's definition, not the decorator, the wrapper. We need to have this here, and when we call the function, we can just pass this in here as well, so that any argument that we pass in here is going to be reflected when we call our function, as you can see here. So now if I run this code, I can do admin, and we can see some random book has been borrowed. So this is kind of a more practical example of using decorators in Python programming. There are also loads of other examples that you can use with decorators, such as if you want to determine the time that a function takes, then you can define a decorator and wrap a function with 2 times, and then find the difference between the 2 times, and then you have the time that that function takes. And that's just one of the examples that you can try out on your own. Now, to summarize, in some Python libraries and packages, almost every function you define needs to be decorated in some way for them to function properly. And for the most part, you don't necessarily need to write decorators yourself that often. Hopefully this lesson has provided you the information that you need to do so if you would so like. And you also understand how decorators work internally. And that is it for this video on decorators in Python programming. If you found this tutorial to be helpful, please consider subscribing down below and leaving this video a thumbs up. With that said, thank you for watching this video and happy programming!